Dear students, today we will discuss properties of electric charge. We'll see one by one. First one is like charges repel while unlike charges attract each other. So this you have already learned in class 10 standard. So I won't discuss much about this, but you can see the diagrams given in the textbook, maybe page number 2. You can see the repulsion between two positively charged objects and attraction between two objects which are oppositely charged. Next is charge is unaffected by motion. So to understand this, if you consider an electron to be at rest which has charge 1.6 into 10 to the power minus 19 coulomb, if you want that electron to be in motion also, then charge will not change. That means its charge remains 1.6 into 10 to the power minus 19 coulomb. This is applicable to all other charge bodies. Number 3 is additivity of charges. So it means charges are algebraically addable. If you consider a system containing n number of charges like q1, q2, q3, q4 up to qn, then according to additivity of charge, total charge of the body is equal to this q1 plus q2 plus q3 plus q4 up to qn. Now if you consider a system containing 4 charges q1, q2, q3 and q4 like this, you can see here. And now if you want to calculate the total charge, so it will be like this. Now you see here q1 is equal to 2 coulomb, q2 is equal to 3, q3 is equal to minus 3, q4 is equal to 4. So total charge of the system is 6 coulomb. This is algebraic addition. You can see q1 is equal to 2, q2 is equal to 3, q3 is equal to minus 3 because it is negative charge. So q4 is equal to plus 4, so total is 6 coulomb. Now sometimes question may arise like this: what does q1 plus q2 is equal to 0 signify in electrostatics? So it is understood that it is in accordance with the additivity of charge. That means for a system q1 plus q2 is equal to 0, it is possible only when these two charges are of opposite nature and their magnitude is same. Like if q1 is equal to 5 microcoulomb, then q2 also should be equal to minus 5 microcoulomb, such that total charge of the system is equal to 0. So algebraic addition, you have to see 5 plus minus 5 is equal to 0. So this is what is additivity of charge. The summary is charges are algebraically addable. Next is conservation of charge. Now you have already learned this conservation. According to this, you cannot create or you cannot destroy charge, but you can transfer charges from one body to another. So you have already learned electrification, and in that you have seen the transferring of electrons from one body to other. Again, you can take the same example here. Like you can see this two neutral bodies. This is object A, which is neutral because equal number of electrons as well as protons, and this is object B, which is also neutral. Now if you consider this two body system, I mean this is a system containing two objects A and B, both are neutral, total charge of the system is 0. Now if you want to rub them and if you want to transfer electron from one body to other, say example electrons are moving from here to here, transferred from here to here, then you can see this body becomes positively charged and this body becomes negatively charged. Now as we already discussed, by what amount this body becomes positively charged, by the same amount this body becomes negatively charged. Now if you consider that number of electrons transferred from this body to this body is 5, now charge acquired by this body is plus 5e, and charge acquired by this body is minus 5e, where e is the electronic charge. That is the simplest possible charge exists. Okay, so a body cannot have charge less than e, that is electronic charge. So here you see 5e plus minus 5e is equal to 0. So total charge of the system is also equal to 0. So before rubbing also it is 0, after rubbing also it is found to be zeros. So charge is conserved. So if you take the real example, like already we have discussed the electrification, and in that we took the example of glass and silk. In that also you can see that before rubbing both were neutral, glass and silk, and after rubbing one becomes positively charged, like glass becomes positively charged and silk becomes negatively charged by the same amount, such that total charge of the system also 0. So this is what is conservation of charge. You can even see the nuclear reactions, any nuclear reactions. So if you recall beta decay, which you have already learned in um, class 11 standard, in that you can see one neutron converts to proton, along with that proton one electron and one antineutrino emits. In that also if you see the atomic number of both sides, it remains the same. You know, atomic number indicates the number of electron as well as number of proton. So if you see the beta decay reaction also, in there also you can see that charge is conserved. Next is quantization of charge. Now you can see the statement first. The charge of any object is equal to integer multiples of the elementary charge. This is known as quantization of charge. Elementary charge means electronic charge. So electronic charge is considered to be the simplest possible charge. That means you cannot divide an electron. The meaning is that. So Q is equal to plus minus Ne. Plus minus Ne means the charge can be positive, the charge can be negative. Total charge on a body can be positive, can be negative. So Q is the total charge, where small is the electronic charge. So Q is equal to plus minus Ne, where N is integer. That means you cannot take um, fraction values, like it cannot be half e, it cannot be 1.5e, it cannot be 2.1 2.1e. This is not possible. So the meaning is that the meaning is that you can only transfer a whole number of electrons, like um, you cannot transfer 1.5 electron, you cannot transfer 2.1 electron. So you can see this line, the basic cause of quantization is that only integral number of electrons can be transferred from one body to another on rubbing. So you can transfer 5 electron, you can transfer 15 electron, you can transfer 20 electrons, but you cannot transfer 20.2 electrons. This is not possible. Also, one point you need to remember here is quantization is not applicable to macroscopic objects. You can see this, quantization is not applicable in macroscopic objects. For this you have to take one example and you can understand this. Like so if you imagine our basketball court of our school, say example, and if you imagine that 5 people are standing there, so definitely you can differentiate those 5 people. Okay, you can see those 5 people clearly, you can count them clearly. But instead of 5 people, if you consider say example 2000 people there in the same ground, then what will you see? You will see as if it is continuous. So if you imagine 5 people are standing there, so these are discrete values. Okay, there is a gap between 2 people, there is a gap between any 2 people, you can see the gap. So accordingly we can see it as discrete values. Okay, discrete values. Now the opposite is continuous values. Now instead of 5 people, if you consider 3000 people there in that ground, so you won't be able to count one by one. Rather, it looks like continuous, huh? It looks like continuous. So this is what is quantization. So it is not applicable to macroscopic object, in the sense the value of n is too large. For macroscopic object, the value of n is too large, so you cannot um, apply it to macroscopic objects. So let us think this. You can see this. Number A, is a charge of 10 to the power minus 21 possible? Now in this you can see that the value is less than electronic charge, which is 1.6 into 10 to the power minus 19 coulomb. So definitely it is not possible. Already we have discussed that the simplest possible charge is 1.6 into 10 to the power minus 19 coulomb. So this 10 to the power minus 21, this value is less than 10 to the power minus 19. Okay, so this is not possible. Number B, a body has charge 3.2 into 10 to the power minus 19 coulomb. Is it possible? Now in this case also you can see, you can apply Q is equal to plus minus Ne. Now here it is plus because it is positive. You can see the positive sign. Charge is positive. So what is the value of n here? The value of n here is 2, because it is 2 into 1.6 into 10 to the power minus 19. So it is 2e. This is nothing but 2e, twice the electronic charge. So 2 is integer, so this is possible. Third one, you see a body has charge 5 into 10 to the power minus 19 coulomb. Is it possible? You can see here. So if you apply Q is equal to Ne, so here n is not an integer, so definitely it is not possible. So sometimes you may get it directly, sometimes you may not get it directly. You have to apply Q is equal to, sometimes it will be asked, is a charge of plus 2.1 E possible? So 2.1 E, so here 2.1 is the n, so definitely it is not possible. But instead of asking that way, they may ask this way also, like 3.2 into 10 to the power minus 19 or 5 into 10 to the power minus 19. So you have to write in that form, standard form, Q is equal to any form. Now here n is equal to 2, so it is possible. Here n is not an integer, so that is why it is not possible. Fine. Next, you see how can you apply Q is equal to plus minus Ne while solving a problem. First one, you see, calculate the charge on a body of 105 electrons have been added to it. Calculate the charge on a body if 105 electrons have been added to it. So in this also you can see we are applying Q is equal to plus minus Ne. So it is electrons are transferred from one body to other, so that final body becomes negatively charged. So your answer should be negative. Okay, your answer should be negative. Applying Q is equal to Ne, you see Q is equal to n. Here n is 105 into E, so total charge is minus 1.6 into 10 to the power minus 14 coulomb. Next is problem 2. You can see, find the number of electrons transferred to charge a body by 1 coulomb. The same thing you have to apply Q is equal to plus minus Ne. So here Q is equal to 1 coulomb. So instead of Q is equal to, in place of Q you have to write 1. In place of Q you have to write 1 and E. So E is 1.6 into 10 to the power minus 19 coulomb. So n is equal to 6 into 10 to the power 18. I think this value is very familiar to you. This is the number of electrons that can give you 1 coulomb charge, that you have already learned in class 10 standard. Third one, you see, a polythene piece is rubbed with wool and it has been found to acquire a negative charge of 3 into 10 to the power minus 7 coulomb. How many electrons have transferred from wool to polythene piece? How much is the transfer of mass from wool to polythene takes place? So here also you have to do the same thing. You can take it as your homework. Apply Q is equal to Ne. Me, mass of electron, is equal to 9.1 into 10 to the power minus 31 kg. Okay, you can see this also. Since electrons are added, so the charge on the body is negative. That already we discussed. Next problem is how much positive and negative charge is there in a cup of water of 250 gram. Now if you consider um, a cup of water of 250 gram, first you have to calculate what is the number of molecules present in 250 gram of water. So this is number of molecules present, capital N I am using, is equal to this Avogadro's number into 250 divided by 18, because 18 is the molecular mass of water. So number of electrons or protons present in this, you have to multiply it by 10. You have to multiply it by 10 because water contains 10 electrons. Okay, water contains H2O, for hydrogen 2, for oxygen 8, so total 10 electrons or protons. So molecular mass of water also 18, that also you need to know. So number of electron or number of proton present in a cup of water, it becomes 8.36 into 10 to the power 25. Fine. So total negative charge carried by electrons or proton, Q is equal to 1.33 into 10 to the power 7 coulomb. For electron it will be negative, for proton it will be positive. Q is equal to 1.33 into 10 to the power 7. Again I am telling this. You see the mass of water 250 gram. So what you have to calculate, number of molecules present, because it is H2O is a molecule. So number of molecules present, you have already learned in chemistry how to calculate number of molecules. Okay, for 1 mole or for a particular mass. Now for 1 mole, it is 6.02 into 10 to the power 23. You have already number of molecules, you have already learned this. So here in this case, number of molecules 6.02 into 10 to the power 23 into 250 gram, because the mass of water given here is 250 divided by 18, because 18 is the molecular mass of water, so it becomes 8.36 into 10 to the power 24. That means number of molecules present in 250 gram water is 8.36 into 10 to the power 24. Now what we have to calculate is number of electrons and protons present in that 250 gram of water. So for that you have to multiply this by 10, because there are 10 number of electrons in a water molecule, because you see water contains 2 plus 8 is equal to 10 electrons or proton, 2 for hydrogen H2 and 8 for oxygen O, H2O. So the result is coming out to be like this. So total negative charge carried by electrons or proton, Q is equal to Na. Total negative charge carried by electrons, definitely for electron it will be negative, for proton it will be positive. So Q is equal to this value, negative value for electron and positive value for proton. This is all about for today. Thank you very much.